scratch.mit.edu is a cloud-based programming environment on MIT servers. You can also download it offline on your own Mac or PC. And it gives you an interface like this. On the left-hand side of the screen, you'll see a blocks palette. These puzzle pieces, aka blocks, come in different colors, which rather categorize them. So pictured here, for instance, in blue, are a whole bunch of motion-related blocks. So Andrew used a whole bunch of those to have the singer and the men moving around on the screen in synchronicity with the song that was playing in the background. Meanwhile, in the middle of this interface is going to be the code area. And this is where Andrew and soon you will drag and drop some of those puzzle pieces and other colors as well and lock them together to get your characters, soon to be invented, to do something on the screen. Indeed, at the bottom right here, will you see ultimately a sprite area, where a sprite is a technical term for like a character in a video game or a programming environment like this. By default, historically, Scratch is the cat, the mascot, if you will, for this programming environment. And so here we see by default just one sprite selected, because on the top right of the screen is the stage for that sprite. And you can click and zoom in to make it full screen. But this is the world in which Scratch, by default, the cat, will live. But you can change Scratch's costume so that it looks like a singer or a man falling from the sky or the like, or anything else, either creating the art yourself or importing some of the things that come with it or elsewhere online. So what is this world that Scratch rather lives in? Well, generally speaking, we won't have to care too much about numbers, because we'll be able to ask questions like interactive ones, like is Scratch the cat or any character otherwise, touching the edge of the screen, touching something else. But Scratch does exist in this two-dimensional coordinate system world. So when the cat or any character is dead center in the middle, that would be XY location 0, 0, if you will. Meanwhile, over here is 240 pixels or dots all the way to the right. So this would be 240, 0, where y is 0 because it's right on that midline. So it's neither up or below. Over here to the left, of course, would be negative 240 and 0. Above the cat would be x equals 0, because it's right on that vertical midline, and 180. And then down here, as you might guess, would be 0, negative 180. Generally speaking, we don't have to care about those precise pixel coordinates, but it's helpful ultimately if you do want the cat to move up, down, left, or right. Having some sense of direction according to the x-axis and y-axis as well can help you express your ideas ultimately. So what might some of those ideas be? Well, let's do this. I'm going to go ahead and create on scratch.mit.edu just an empty screen like this one here. And so this is the exact same interface, but now I'm in my browser, full screen, so that I can start writing some code. And let's get that cat to say something actually on the screen. Now, this takes a little bit of practice, but honestly, just by scrolling through these puzzle pieces, can you quickly get a sense of what's possible, not just categorically, but specifically? And I'll jump around, because I've done this, of course, before. But I'm going to go to events in yellow first. And I'm going to drag and drop this first block called when green flag clicked. And I've zoomed in there just to make it a little more legible. And notice that the shape of this green flag just so happens to mirror this green flag here at top next to this red stop sign of sorts. And the green flag is going to mean go, and the red stop sign is going to mean stop, to start or stop our program. Next week, you're going to be writing a textual command at your keyboard to do the exact same idea, but for now it's a button. So when green flag clicked, what do I want Scratch to do? Well, how about we have Scratch just initially say something like hello world, which indeed historically is the first program that most any programmer might write. So anything related to what the cat looks like it's doing is actually going to be under looks here in purple. So I'm going to drag over say hello. And you'll notice something curious and different about this purple block. It says, of course, say in purple. But then there's this white oval and some text that by default is hello, because MIT just decided that by default the placeholder will be hello. But anytime you see this white oval, it's an opportunity to provide an input into the function called say. And so here I'm borrowing terminology from before. Problem solving, again, is all about inputs, producing outputs. And in between there is some algorithm. In a moment, we're going to start referring to algorithms quite frequently as functions. Why? Because it's the implementation of some algorithm. So let me override the default with hello, world. I'll zoom out. And now if I go to the top right of the screen and click the green flag, we'll see, hopefully, my very first program in code. Now, it wasn't a huge lift, right? It only was a matter of dragging and dropping puzzle pieces. But what has now happened? Well, it turns out that two things have happened. When I, the human, clicked on that green flag, I triggered what we're going to start calling now an event. An event is generally something graphical or interactive that just happens in a computer program. You and I trigger events on our phones all day long. Whenever you tap or drag or long press or pinch or any of those gestures in vogue nowadays on phones, you are triggering events. And people at Apple and Google and elsewhere have written code that listen for those events and do something when that event happens. That's what I just did. When green flag is clicked, I want something to happen. Namely, I want this purple function, this verb, this action called say, to do something. What do I want it to do? I want it to say what this input is. And I'm going to introduce another vocabulary term. The white ovals here are, yes, inputs very generically. But in a programmer's terminology, they're called arguments, otherwise known as parameters. And that just means an input to a function that modifies its behavior in some way. When I click stop, that's just another event. And that one is just built into Scratch. Scratch knows that when you click the green stop sign, everything should just stop automatically. I don't have to write code to support that feature. So that's all fine and good. Hello world. But if I keep doing stop and start and stop and start, it's going to do the same thing again and again. And it's really not that interesting at the end of the day. Maybe gratifying once, but it'd be nice if this were a little more interactive. This may be perhaps more interactive and actually get the cat to say something a little more dynamically. So instead of hello world, why don't I get it to say hello to me or to you or anyone else? So let me do this. Let me go under, say, let me get rid of this first. And you'll notice this neat trick. As soon as you start dragging on a block, if it gets close to it, it kind of goes gray, and it can be magnetically snapped together. You don't have to do it very precisely. Conversely, if I want to get rid of a puzzle piece, I can just drag it anywhere on the left, let go, and that deletes it. Or you can right-click or control-click, and a little menu will let you delete it as well. Well, let me do this instead. Under sensing, which I know is there because I've done this before, are a whole bunch of things related to sensing, whereby the cat can kind of feel out its world in some sense. It can do things like ask this question. Am I touching the mouse pointer, like the user's cursor? Am I touching a specific color that you can override to be anything you want? Is the distance to the mouse pointer some specific value? But for now, I'm going to focus on this blue puzzle piece that asks a question, which itself is this white oval that I can apparently change. And then it's going to wait for a response. But this puzzle piece is a little different. It's a little special. It comes with a freebie. It comes with what we're going to call technically a return value. So some functions don't just do something on the screen. They hand you back, so to speak, a value that you can do anything that you want with. Nothing happens immediately unless you do something with that so-called return value. So let me go ahead and drag this thing over here. Ask what's your name. And I'll use the default question. That seems a reasonable place to start. I'm not going to override that default. And now let me go ahead and zoom out. Let me go back to looks. Let me go to say, and let me just form the English sentence I want. So let me zoom in here and type in hello, maybe comma, space. I could do David, but that's obviously not right because I'm asking for a name and then I'm like in advance hard coding my name. That's not what I want. I just want hello, comma. And now let me zoom out and grab one more say block. Let me maybe say here. OK, I don't want to say hello, hello. I don't want to just type in my own name because, again, then what's the point of asking the user for their name? But notice this. If I go back to the sensing block, this is where that oval that's blue called answer is useful. This will be the so-called return value of that function. So I'm just going to go ahead and do this and drag and drop. Even though it's not the right size, it is the right shape. And so Scratch will be smart about it and grow to fill that puzzle piece for you. Let me zoom out now. And now let me click the green flag. You'll see that Scratch is indeed prompting me with the speech bubble. What's your name? Notice the little text box below the cat is asking what's your name. So I'm going to type in DAVID and hit enter. Or I can click the blue check. Enter. OK, it's a little weird. I wanted him to say hello, not just my name. So let me stop. Let me start it again. All right, hello, what's your name? DAVID. Enter. Huh, kind of rude. Why is there this bug? Like, I wanted to say hello, David, not just David. And yet twice it has failed to do so. Yeah, the computer is processing my directions, my actions really quickly. And so it actually is doing it. It's just you and I in the room are just way too slow to notice that it said, hello, David. It just seems to have just said David. So, all right, how can I fix this? Well, here's where you start to poke around and think about how you might solve this. Let me go back under looks. Maybe there's a smarter way to do this. Maybe I could do, OK, I could do this. How about instead of just say hello, there's apparently another puzzle piece where I can time it. So I can maybe slow things down a little bit. So let me do this. Let me throw away all of this. Let me drag a say hello for 2 seconds. Let me drag another say hello for 2 seconds. Let me change the first one to indeed hello, comma. And then let me go back to sensing. Let me grab that same answer, because I threw it away a second ago, and I'll just change it. I don't even have to delete hello. I can just overwrite it like this. So now I think we'll kind of pump the brakes and see things more slowly. Let me stop. Let me start. DAVID, enter. Hello, David. OK, so it's better. Like, it seems to be working. I think your hypothesis was right. It just looks kind of stupid, right? Like the fact that it's saying hello, David, like we can do better. And like literally every piece of software on your phone or Mac or PC is better than that. It adds words together in the user interfaces you and I are familiar with. So let's go a little more fishing here. Let me throw away these. Let me go back to looks and just get the simpler say. I want this to say hello, comma, name, where name comes from that answer return value. So how can I do this? Well, let me go under operations, which we haven't been before. There's a lot of stuff in here. Some of it's mathematically related, adding, subtracting, and so forth. You can generate random numbers, which might be useful. And if I keep scrolling down, there's this join apple and banana. But that's just placeholder text. You can join one piece of text with another piece of text. By default, apple and banana, but let's change it to hello and my name. So this too, wrong size but right shape. So let me let it snap into place. Let me go ahead now and do hello, comma. And now I think I just want to go grab that answer return value. Let me drag the same oval as before, clobber, that is overwrite banana. So now I'm kind of composing functions. The output of one function, join, is going to be the input of another function, say. So let's see what happens now that they're kind of stacked on top of each other or nested, so to speak. Click the green arrow, a green flag, DAVID, enter. Hello, David. All right, that was pretty fast. Let's just do it once more. Stop, start. Here we go, DAVID, enter. OK. Right, it's not the most exciting program in the world, but it's more correct. It's better designed just because that's what you would kind of expect the software to do and not be some kind of lame user interface that's just inserting random delays to just make it kind of work. Like that's a workaround, a hack, if you will. But there's some cool things you can do with Scratch. And we won't really go down the rabbit hole of all of the fun and family-friendly features that it has. But there is one that's kind of cool here. Let me go into the extensions button at the bottom left of my screen. And this one's kind of cool. Let me go to text to speech. And you'll notice that this one requires internet because it's cloud-based. But this just gave me some new puzzle pieces in a new category, text to speech. And these green ones do exactly what they say. So let me do this. Let me zoom out again. Let me keep the join block. And I'm just going to temporarily toss it over here. It's not going to delete itself because I didn't drag it over to the other side. But I'm going to get rid of the say block in purple. I'm going to do the speak block here in green and let it snap into place. And then I'm going to drag and drop this onto the input to speak. And now, perhaps a little more adorably, let's try this. Green flag. What's your name? DAVID. Enter. And?
Hello, David.
OK. It's a little robotic, but at least now it has synthesized speech. And I've kind of got my own like Siri or Google Assistant or Alexa thing going on here now, where it's now recognized whatever text it is and it's played it. Well, let's make this an actual cat that doesn't talk in that weird human voice. Let me go ahead and get rid of most of this stuff. And let's get the cat to actually meow like a cat tends to. And let me go under the sounds block. Now, MIT gives you a few sounds for free because it's designed around a cat by default. And I'm going to go ahead and grab this one. Play sound meow until done. And now, and we heard a teaser for this earlier in the crowd. It's a little piercing, admittedly. We can lower the volume a little bit there. But notice if I want the cat to meow a second time, I'll just click it again. OK, and over there too, I hear. OK. All right, so it's kind of cute now, right? So it's just meow. OK, yes, echo, echo. So it's meowing now every time I hit the green flag. Now that's great, but even a kid is probably going to would prefer that it just meow, perhaps, like again and again without having to keep hitting the button. So well, how might we do this? All right, well, if I want it to meow multiple times, why don't I just grab it another time and another time? Alternatively, you can right-click or control-click a puzzle piece and just duplicate it from a little menu that drops down. So here we go, 3 meows. All right, that's not really a happy cat, it sounds. Maybe hungry. So can we slow that down? Well, maybe. In fact, if I poke around, let me go under control. Looks like there's a wait block. Wait 1 second by default. And notice, Scratch will be pretty accommodating. If you just hover in between blocks, it will grow to fill that too. So I could change it to 1 or 2 or anything seconds. I'll just leave it at the default for now, 1. And now I'll go ahead and do this. OK, so cuter and less hungry and just more friendly. But this isn't the best design. It is correct. And let's use that as a term of art. Correct means the code does what you want it to do. I want the cat to meow 3 times slowly, and it did. So I'd wager this is correct. But it's not the best design. And this is where things get more subjective, right? Like you could write accurate sentences in an essay for an English class, but otherwise it's just completely a mess. Like your arguments here and there, and you don't say anything wrong, but you don't say it well. In the context of code, we can do better than this. And copy paste or repeating yourself again and again tends to be bad practice. Why? Suppose that you want to change the wait to 2 seconds instead of 1. It's admittedly not a big deal. Fine, I click there, I change it to 2. I click there, I change it to 2. But what if you meow 5 times, 10 times? Now I have to change the wait like in 5, 10 different places? Like that's just stupid. It's taking unnecessary human time. And you're going to screw up eventually. Especially if your program's getting longer, you're going to miss one of the inputs. You're going to leave the number wrong, and that's a bug. So just based on what you've seen already, or if you've programmed before, which a few of you have, what's the term of art here that will solve this? How could we design this better? I heard it here. Yeah, so a loop, some kind of cycle that says do that again, do that again. Not infinitely many times necessarily, but some finite number. Well, you can perhaps see a spoiler on the screen. Under the same orange control category is a repeat block. And by default, it's proposing 10, but we can change that. So let me do this. I'm going to throw away most of this copy paste as redundant. I'm going to detach this temporarily just to make room for something else. And I'm going to drag a repeat block over here and let that snap into place. And I'm going to change it for now just to be 3 for consistency. And this is the correct shape, even though it's too small, but Scratch will accommodate that for us. And now, same output, but arguably better designed. Why? Because if I want to change the number of meows, I change it in one place. No copy-paste messiness. If I want to change the weighting, one place. I don't have to change it in multiple places and not screw up. So let me hit the green flag. All right, so nice. Now, it would have been nice if MIT had just given us a meow block that just automates all of this for us. Let me wager they gave us the low-level implementation details. They gave us the play sound meow. But I had to implement like a decent number of blocks just to get a cat to meow again and again. I feel like we should have gotten that for free from MIT. Well, they don't have to be the only ones that invent blocks for us to use. You can write your own functions, your own verbs or actions. So how can we do this? Let's make our own puzzle piece called meow that uses this code but creates it in such a way that it's reusable elsewhere. So let me do this. Under my blocks in pink here, I'm going to go ahead and click literally make a block. Now here's an interface via which I can give the block a name. MEOW will be the name of this block. And I'm just going to go ahead and quickly click OK. That just gives me a very generic pink puzzle piece that starts with the word define, because Scratch is asking me to define, that is, implement or create this new puzzle piece for me. Well, what does it mean to meow? I'm going to claim that it means to do these 2 steps, to play the sound meow and then just wait for 1 second. But what's powerful about this idea is look at this up top. Now that I've made a block, it exists in Scratch. MIT didn't need to create this for me. I created it for myself, and even you if we end up sharing code. So I can now drag meow up in here. And what's nice about meow is that itself is, yes, a function, but it's also an abstraction. Like never again do I, or even you, need to worry or care about what it means to meow or implement it. I can sort of drag it out of the way. I didn't delete it. Drag it out of the way, out of sight, out of mind. Why? Because my code is now even better designed in some sense because it's more readable. What is it doing? When the green flag is clicked, repeat 3 times, meow. It just says what it means. And so it's a lot easier to read it, and it's a lot easier to think about it, especially if you're using meow in other projects too. Now, let me go ahead and hit click play. Same thing. So it's not really fundamentally any different. But I could make this custom puzzle piece, this own function of mine, meow, even more powerful. Let me kind of rewind a bit and go to my meow puzzle piece. And I am going to control click or right click on my pink puzzle piece. And I'm going to edit it. So I kind of regret making meow so simple. Wouldn't it be nice if meow took an input, aka an argument, that tells meow how many times to meow? Then I can get rid of that loop and just tell meow how many meows I actually want. So I'm going to click on another button here called literally add an input. And it's going to have placeholder here. So I'm just going to put a placeholder there. I keep using n for number, which is a go-to in computer scientist terms. And I'm going to add some descriptive text just so that it's a little more self-explanatory. I'm just going to say meow n times. But there's only one oval. Times is just going to be explanatory text. And now notice what has happened. Now my puzzle piece takes an input, aka an argument, that will tell that function to meow some number of times. But it's not just going to work magically. I need to implement that lower level detail. So let me zoom out. I have to remind myself what this function was. So I'm going to drag it higher up just so they're on the screen at the same time. I'm going to go ahead now and temporarily move this over here. I'm going to temporarily detach this over here. Why? Because what I think I want to do is move my loop into the function itself, move the play and the wait into the loop, but I don't want to hard code 3. Notice that n here is its own oval. I can drag a copy of n and just let it go there. So now I have a new version of meow that takes an argument, n, that tells meow how many times to meow. And now, let me again drag this out of sight, out of mind, because who cares how I implemented it? Once it's implemented, it's sort of done. Now my program is even better designed in some sense. Why? Because now it really just says what it means. There's no loop, there's no repeat, no like implementation details. When green flag clicked, meow 3 times. And so functions indeed let you implement algorithms, like they're just code that do something for you, but they're also themselves abstractions. Why? Because once a function exists, it has a name, and you can think about it in that term, and you can use it by its name. You don't have to care or remember how the function itself was built, whether it's by you or even MIT. So again, here, I'll click the green flag. It's the same thing. So still correct, but better and better designed. And so anytime here on out with Scratch or soon C and eventually Python, when you find yourself doing anything resembling copy-paste or again and again grabbing the same code, probably an opportunity to say, wait a minute, let me refactor this, so to speak. That is, rip out the code that seems to be repeated again and again and put it in its own function so you can give it a descriptive name and use and reuse it. Any questions just yet on now saying or these loops or these functions that we're using? Yeah. How did I make it so it meows 3 times? So I originally only had a puzzle piece called meow, and I decided to improve it. So I held down Control, and I right-clicked or Control-clicked on the pink puzzle piece at top left, and I clicked Edit. And that brought back the original interface that lets me add some arguments to the puzzle piece itself. And I clicked Add an Input on the left here, and then I clicked on Add a Label over here. So that just lets you customize it even further. All right, so we've done this. Let's add one of those other primitives, too, to do something optionally. So how about we make the cat meow only if it's being petted by a human, as by moving the mouse to hover over the cat like a human would pet a cat? Well, let me go ahead and throw away the meowing for now. And let me simplify it by just using a sound. I'm going to go ahead and do this. I'm going to go ahead and have a control block that says if, because I want to implement the idea of if the cursor is touching the cat, then play sound meow. Or I could use my same pink puzzle piece, but I'm going to throw that away and focus only now on the sounds. And I'm going to do this. If touching mouse pointer. So I need to sense something about the world. And we saw this earlier. So if touching mouse pointer. So notice this shape here, way too big, but it is the right shape. So if I hover just right, it'll snap into place. And this now in blue is my Boolean expression, a yes/no question, true, false. If is a conditional. And what do I want to do? Well, if the cat is touching the mouse pointer, I want to go ahead and play sound meow until done. So let's do this. I'm going to hit green flag, click. Now nothing's happened yet because it's a conditional, right? It's only supposed to do something if I'm touching the cat. Let me move the cursor over to the cat and wait for it. Another bug. Why is the cat not meowing? Even though I very explicitly said, if touching mouse pointer, meow. Yeah, in the middle.
Does it ask the question the
Yeah, this is, again, my computer's just so darn fast, like yours. I click the green flag. It asks the question, am I touching the mouse pointer? Well, no, because my cursor was up there, not touching the cat. It's too late. The cat's out of the bag. And so we have to instead solve this by some other means. How can we fix this? How do we fix that sort of race? Yeah. Yeah, so why don't we just keep asking the question until I eventually am or am not actually petting the cat? So let me detach this temporarily. Let me go under control. Let me go under, instead of repeat some finite number of times, let's just do it forever. So sometimes loops that do work forever are a good thing. Like the clock on your phone, that's in a loop forever because you want it to always tell time and not stop at the end of the day. So sometimes you do want code to loop forever, as in this case. So let me go ahead and drag and drop it there. Let me again click the green flag. Nothing's happening yet, but notice the program's still running. And so if I move my cursor, and oh, OK, so maybe we could add some waiting, but the cat does not want to be pet in this case. But it's indeed conditional. So there we have an incarnation in Scratch of doing something conditionally. Now we can make this really cool, really fast, if you will. Let me stop this version. Let me go ahead and do this. Let me go ahead and throw all of this away. Let me go into my little extensions bucket over here. And let me do video sensing, since most laptops or phones these days have cameras. And there, indeed, I am with Sanders behind me. And let me do this. When video motion, and let me get out of the way. When video motion is greater than some value, so 10 is the default. This is just a number that measures how much motion there is or isn't. So small number is like no motion. Big number is lots of motion. So I'm going to choose 50 somewhat arbitrarily here. So 50. This is not normal to program off to the side. But I'm now going to say this. When video motion is 50, go ahead and play sound meow like this. So the cat is still in that world. I'm going to stop the program and rerun it. So here we go, green flag. And now, here come, all right, this is a little creepy the way I'm petting the cat, but, and, OK. There we go. OK, so 50 was too big of a number. I have to pet the cat faster. Whereas this, if, I don't know. Yeah, so. OK, so you can make things even more interactive in this way by just assembling different puzzle pieces. And honestly, there are so many different puzzle pieces in here. We're not going to even scratch the surface of a lot of them. But they generally just do what they say. And indeed, when you see on the screen here, this palette of puzzle pieces, really a lot of programming, especially early on when learning a language, is just trying different things and try and fail. And if it doesn't work quite right, look for an alternative solution there too, as even I just had to do a moment ago. Should be anyway at this point in my life. But this song is synchronized then with a lot of the actions that's happening. And ultimately, there's just a lot of building blocks. But I didn't sit down and implement Oscar time, as I called it, all at once. I really did take baby steps, so to speak. And I figured out, well, how could I decompose this vision I had at the time to create this game ultimately? And how do I bite off maybe the easiest parts first? And honestly, the first thing I did was I found this image, and I just like dragged and dropped it into Scratch. So OK, done. Like lamppost is installed. It doesn't do anything. It's not interactive. But I at least set the stage, so to speak, for the program. Then what else might I have done? Well, let me do this. Let me go ahead and open up in another editor here a early incarnation of Oscar time by doing this. Let me go into Oscar time here. Let me full screen this. And here you have, let me hide the trash for just a moment, is what I might call the second version of my program, wherein at the top right of the stage here, I had the lamppost, which I just dragged and dropped and got going. But then I added an actual sprite. And it has to be a sprite if you wanted to do things interactively. The lamppost, not a sprite. It's just an image, a costume, if you will, for the whole stage itself, a backdrop. But this thing is indeed a sprite because it needs to respond to code and events like dragging and dropping. So what might I have done early on with that code? Well, maybe the first version would have been something like this, whereby my very first version of Oscar time might have said something like, oh, this. How about let me control the program as before, or rather events. When the green flag is clicked, what do I want to do? Well, I want to go ahead and forever do something like this, forever. So I want the lid to open up if I touch it. So if the cursor gets near the lid, I want the lid to open up. And then if I move away, I want it to close. So how can I do that? I want an if, but I just don't want one question. I really want two, a fork in the road that goes left or right, so to speak. And let me grab this puzzle piece here as I did long ago. So notice it grows to fill. What's the question I want to ask? Well, under sensing, I'm going to go ahead here and say if this trash can is touching the mouse pointer, what do I want to do? Well, I want to change what the trash can looks like. And this part I did in advance of class. If you go up here to costumes, this is where all the graphical stuff happens. And you'll see that I imported a whole bunch of different costumes that effectively, much like a video, when you play them quickly, creates the illusion of movement, some animation. But it's really just dot, 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 different images showing on the screen. Well, some of these costumes are called like Oscar 1, Oscar 2. Oscar 1 is closed. Oscar 2 is open. So let's just deal with those first. So if I'm touching the mouse pointer, let me go under, how about looks? And we didn't use this before, but there's this block. Switch costume to something else. I'm going to drag and drop this inside of the if. And notice it's a little bit indented. I'm going to change it not to Oscar 8, but Oscar 2. Otherwise, if not touching the mouse pointer, this is the other direction in the fork in the road, let's go ahead and switch the costume back to what I described as Oscar 1. So let me run this program. And not much of interest is happening yet. But notice if I move the cursor up, down. But how is that working? It's just changing the costume that's being overlaid on the sprite. So it looks like interactivity, but you're really just changing the aesthetics. And we humans are just kind of, assuming, oh, it's opening up. Well, no, it's just changing a costume. So here's the difference. The high-level abstraction, trash can opening. The lower-level implementation detail, costume changing, creating that illusion. And if I wanted to look prettier, I could just have many other costumes and go boom, 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 boom to create more frames per second, if you will. So I need to do one other thing, maybe if I accidentally leave the trash can open, let me make one change here. Let me make sure that the very first thing I do when the green flag is clicked is always start with the trash can closed, because otherwise you might accidentally leave it open. So this gets me into some default state. So now it's always closed until I manually hover over it instead. Well, what might I have done next? Well, if I wanted to introduce something like the trash, I need a second sprite. And here in advance, I grabbed the image already. Let me pretend that this never happened. Let me drag this away here. And now I have nothing in my code area for this piece of trash. But it is a second sprite. And all I did was I clicked on the little cat plus icon here, created a second sprite. I named it trash. I added a costume for it, sort of the aesthetic stuff I did in advance. But here I'll do now the code. How do I want to do this? Well, how about when the green flag is clicked for the trash can, I want the trash can in parallel to do, or I want the trash, the piece of trash, to do its own thing. So what I want it to do is maybe, let's do motion, how about? And let's go to a specific coordinate. Now, there's a lot of options here. There's turning, go to a random position, go to x, y, glide more elegantly. There's a lot of different ways to implement movement. I just wanted to go to a very specific location first. So I'm just going to go to x, y first. And I'm going to say x, how about will be, let's not hard code this. Let's just have it be, well, let's do it at 0 initially, and then 240. So whoops, let's do 0, 240 so that this piece of trash always starts at the top middle of the screen if you think back to that coordinate system. 0, 0 is in the middle, 240 is straight above it. All right, now after I do that, what do I want to do? Well, how about I control this thing by forever falling? Now, how do I make the trash move? We haven't seen this puzzle piece yet, but under motion, the very first thing is called move some number of steps. By default, it's 10, but we'll do it more simply. Let me go ahead and move. Move is going to move it in whatever direction it's facing. I only want it to move down. So here, even I'm getting confused as to how many different ways there are to do things. What I think I want to do is this. Let me only change my y-axis as follows. So here's another puzzle piece called change y. So again, y is the vertical. So let me just change y by 1 pixel downward at a time. So -1, 1 pixel at a time. So it's kind of slow. And I think that's it. Let me hit stop. Notice that my trash can is still going to be interactive. I haven't changed or deleted that code. I've just added now code for my trash piece of trash. If I click the green flag, notice that after I enable it, let me start that again. I had it hidden before class, but let me enable it now. Green flag, notice it starts dead center at x equals 0, y equals 240, and it's dropping 1 pixel at a time. If that seems a little boring, we can change it to negative 10 pixels at a time, and boom, it's done. So that's how you might change the speed of a program. But I'm going to leave it more simply as -1. And honestly, it would be nice if it doesn't always start from the top. Otherwise, this game is not going to be very interactive. I'm literally going to be grabbing the trash from the same place every time. So why don't I instead stop this? Let me go under operators, and let's pick a random number. So let me change the hard-coded, the manually inputted 0, and let's make x be somewhere between 0, so in the middle, and all the way over to, what was it, oh, I got my numbers wrong, 240, and my y will be 180. Sorry, I got my x and my y confused. So let me play this again. And now we have a game that's more like games you might have played growing up, or even now, like there's some randomness to it. So the CPU, so to speak, is doing something more interesting. Let me run it again. Now it's a little to the left. Let me run it again. Now it's a little more to the left. Again, now it's back to the right. So randomness just makes games more interesting. And this is why when you play any video game, if different things are happening, there's probably just some randomness. And it's quantized as just a simple number. Now I think I just need one final flourish here, if I may. Let me go ahead and add this. How about events, or rather, yes, events. When green flag is clicked, I can do multiple things within the same sprite. They don't all have to be attached to the same one. Let me go ahead and forever go ahead and do something else. How about whenever the trash is, how about touching the trash can? So forever, if, let's see, I need a sensing block. So how about is touching, not the mouse pointer this time, but touching Oscar himself there. Now let's see what happens. All right, so let's go ahead and click the green flag. Now I go down over here and let go. OK, I kind of want it to go into the trash can. How do I make it go into the trash can? How can we take this high-level idea, put trash into the trash can, and make it seem to disappear? Logically, what could we do? Yeah. OK, so when it touches it, let's have it disappear. So I could hide it. Or honestly, if the game's going to be ongoing like it was, letting me drop more and more trash, let me just have it go ahead and pick a new random location. So let me do this. Let me go ahead and copy this puzzle piece up here and duplicate. And I don't want the whole thing. Sorry. Let me get rid of this. Let me just do this. Let me go back to some random location at the top. So now notice what happens. If I click and drag on it, here it goes, and I let go, it looks like it's going into the trash can because it snaps back up to some random location. Now, the only thing I'm not doing really is keeping track of any kind of score. And it turns out, if I full screen this, it's not going to be draggable by default. So just as a corner case, so to speak, something that you might trip over otherwise, let me go ahead and under, let's see, sensing, it turns out I also need this for the piece of trash. There's this way of setting in Scratch a sprite to be draggable or not draggable. I need to explicitly make it draggable so that when I do full screen this thing now, it still remains draggable. And someone like myself can play it again and again. Well, how about we supplement this with one final flourish? Why don't we keep track now of the user's score? So how about when the user actually drags the piece of trash to the trash can? Let me go under variables here, where in advance I've already made myself a variable called score. I could have called it x or y or z or abc, but that's not very descriptive. In programming, you typically give things a more descriptive English or some other language name. So I called this one score. So how do I want to do this in my score? Well, let me go ahead and initially set this game's score to 0 at the very top of one of these scripts, or one of these programs up here. And then any time my cursor, my piece of trash is touching Oscar, let's not just jump to the top. Let's change the score by 1 up here. So now notice, if touching Oscar, change the score, that is, add 1 to the score, and then pick a new random location. And now, green flag, let's do this slowly. Here it goes. It's the trash can opens. I let go. And now notice at the top left of my program, notice the score is now 2. Notice the score, if I do this again, is about to become 3. And so here we have building blocks, literally, of making this program better and better and better. And so indeed, that's how you generally approach solving any large program, any problem with code, be it in Scratch or C or Python or some other. You take this vision you might have, or some vision you've been assigned in a homework assignment, and try to break it down into these constituent parts. And just pluck off the easy ones first. Put the lamppost there first and at least feel like you're making some progress. Then pluck off something like the trash can and just make it do a little thing. And it doesn't have to be in some same order here. I could have done this in a million different ways, but figure out what the small pieces are that ultimately, like a few of the problems we've solved today, assemble into a greater solution there too. So that you have now a mental model for these types of blocks and others, let's return for a moment to this. We saw a moment ago that when I started saying, hello, David, and nesting those puzzle pieces, we had a whole different paradigm altogether. My input for that second version of hello world was to now pass in, for instance, what's your name, into my function called ask. That gave me not a side effect, but what I called, again, a return value called answer by default in Scratch. And now notice and recall, when I had that same output become the input to my next block, it looked a little something like this, say. So how does this type of block and this nesting, this stacking of blocks fit into the same mental model? Well, same idea. My input for that part of the story is now taking in not one input, but two arguments, hello and the answer from before. The function in this case is that new block called join. The output thereof is hello, David, which itself became, if we sort of animate this, the input to my final function, which indeed was still say. And this is only to say, no pun intended, that almost everything that you do with these puzzle pieces, be it in the context of Oscar time or the mole whacking or even just something simple like hello world, will ultimately fit into that relatively simple mental model there. Now, I thought we'd end by taking a look at just a couple of final examples, these ones too made by some of your predecessors. And for this, I thought we would not write code together, but read it instead. And so allow me to open up one other example here that will show us a few different versions of a program that a predecessor made. Give me just a moment here, and we'll see how we might build up to something even more interactive. And in just a moment, we'll see something they called Ivy's hardest game, focused here on these particular mechanics. So here is version 0, so to speak, of this program, wherein the goal was to create a game where you have to get out of some kind of maze. And you have to get out, in this case, the Harvard crest from this maze. Let me go ahead and just hit play on this green flag so you can see what the first building block for this program might have been. Notice that my hand here is actually on the arrow keys of my keyboard. And it seems that by moving up, down, left, or right, this little crest on the screen responds in exactly that way. Now let's hypothesize for just a moment. Even though we've not done anything quite like this before, how might this code be implemented? How do you get a sprite, be it a cat or a crest, to respond to keys on a keyboard? Might you think intuitively? Yeah. Yeah, there could be something sensing what key you're pressing on. And if you do it again in a forever loop, you'll just constantly be listening for keystrokes. And this is how every piece of software nowadays works. It's constantly waiting for your phone to be tapped or something to be typed on the screen. So let me go ahead and look inside of this existing program here. And there's more going on, but we'll take a quick glance. What's actually going on? Well, up here at top left, notice we just have go to x equals 0 and y equals 0. That means put the Harvard crest dead center in the middle of the stage. Then we have forever two functions that we made in advance as custom functions. Listen for keyboard, feel for walls. So it's doing two things at once. It's forever listening for the keyboard, up, down, left, right, and feeling for the walls in the sense that if I get too far to the left, I don't want it to keep moving past that black wall. And if it moves too far to the right, I don't want it to blow through that wall either. So it's going to do two things constantly, listening for keyboard and feeling for walls, so to speak. And how are those implemented? Well, this one's a bit long, but on the left here is listen for keyboard. So this pink puzzle piece, listen for keyboard, first checks if the key up arrow is pressed, question mark, Boolean expression in a conditional, change y by 1. That means move it up 1. Else if the key down arrow is pressed, then change y by -1. And similar for left arrow, similar for right arrow. And even though there's not a loop in this pink function, there is where I'm using it. So it's constantly being asked again and again. How about feeling for walls? Well, over here to the right, it's a little cut off, but here you have if touching left wall, change x by 1. So if you hit the wall, it's too late. You're kind of blowing through it already. So I want to move it whack 1 pixel so it's no longer touching that wall. Similarly, if it's touching the right wall, I want to back it up 1 pixel so it's no longer touching that wall. So it's kind of like bouncing off ever so slightly so that it doesn't slip through that actual wall. And what are those walls? Well, notice down here, it's just a simple sprite with a black line that I've oriented vertically instead of horizontally. And that's just so that I can ask questions of these other 2 sprites. Now, that gives me that form of interactivity. What more can I now do? Well, what if we make things a little more interactive here? Let me go ahead and see inside version 1, our second. And let me propose what's going to happen here. Well, how might we add a little something like Yale into the mix? Well, what's Yale going to do when I hit the green flag now, based on this code? Any hunches? Here is the code for my Yale sprite. Yeah, it's kind of going to be an adversary by blocking my path, theoretically, if I keep writing more code. So why? It, too, goes to the middle of the screen. It points in direction 90 degrees. So similarly, there's a whole degree system as well. And it forever asks this. If touching the left wall or, notice the green block, touching the right wall, then just turn around 180 degrees. And indeed, if you think this through logically, that just means you're bouncing this way and this way by just flipping yourself around 180 degrees for just this Yale sprite. So if I go ahead and zoom in on this and click the green flag, I can still move up and down. But Yale is just kind of doing this all day long, back and forth forever. Nothing bad happens if I try to go through it, but we could add that, certainly, to the mix. In fact, let's add one final feature before we play this particular game. And let me go ahead and open up the final version of these building blocks that adds MIT to the mix. So here's MIT. Someone want to explain what this code does? And this is what we're doing. This itself is a skill. Reading someone else's code and understanding it is half of the part of programming besides writing. Yeah, it's chasing down the Harvard logo outline. So this is apparently the name of the costume that this student made, Harvard logo outline. And apparently it goes to a random position first, but then it forever points to Harvard. So no matter where I'm moving it, up, down, left, or right, MIT is being a little more strategic than Yale, bouncing back and forth like this. So let's go ahead and play this one in full screen. And here we have a green flag. So if I move up, MIT, rather strategically, is following me no matter where I go. All right, so still nothing bad happens, but and now it's struggling, right? It's going up, down, up, down. It's trying to follow me even though I'm not moving. So we need some final flourishes. And so I think for this, we need perhaps one final volunteer. After this, cake awaits for everyone outside, as is an end of first lecture CS50 is now served. We'll see you next time.